Hello everyone. So today we are going to understand decorator design pattern. It is a structural pattern that lets dynamically add new behavior or responsibilities to objects without modifying their underlying code. Now let's understand what all problems do we face without using the decorator design pattern. So let's take an example. Let's say if you go to a restaurant and if you want to order a coffee, right? So there could be different variants. It could be a simple coffee, it could be coffee with more milk, it could be coffee with sugar. So let's see if we want to implement this scenario, how could we do it without using pattern? So firstly, we will create an interface copy and we will define two methods, which is getting the cost and getting the description. Okay, now we will have a class simple coffee, and simple coffee would implement this interface coffee, and it has to provide the implementation like functionalities of these two methods. And let's say the cost of simple coffee is rupees 100 and its description is simple coffee. Now, let's say there is some new requirement that customers also want coffee with more milk or coffee with sugar. Then, what can we do here? We can implement one more class, which is coffee with milk, which again implements this interface coffee, and it will have its cost and description. So, here the cost would be like simple coffee was having 100 rupees cost, and the coffee with milk would be 120 rupees. And description could be coffee plus milk. Similarly, if user wants coffee with sugar, then we can define cost respectively, which is let's see here 130 in this case, and we can have the description as like coffee plus sugar. Now, if you could see this, this looks simple when the use case is very simple. But let's say in future there are many more variants coming in. So if we go ahead coding this way, we would have for every variant, we will have to define a class, separate class, which is not a good way of writing a code. It becomes a bulkier and also it becomes difficult to manage. Problems faced without using decorator pattern. First thing is class explosion, which we saw right now. So for every new combination of feature, we would need a new subclass. So let's understand, like as I also mentioned, the hypothetical scenario. Let's say the number of subclasses grows exponentially. That could be the scenario, right? That let's say there are n features, then we might lead into to the power n minus 1 combination. So those many subclasses would be there in our code. And if n is very large, there could be the value of to the power n minus 1 would be very much. So that is what is the issue which we face. The second is like the design is rigid. What does this mean is we cannot change the feature at runtime, right? We need to swap the entire object with different subclass. Let's say, I mean, if we want, we'll understand this more better in the code, but it's like the design which we are following right now. Is it like we cannot have an object which could be interchangeably used in our code? I mean, defining every subclass, we are creating objects of every subclass, and then we are calling the respective methods. So that is one drawback, and even it violates open closed principle. So now let's see how can we improvise this way of writing code using decorator pattern. Let's understand when to use this pattern. We want to extend the functionality of class without subclassing it. We could think of this pattern, and we need to compose the behavior at runtime in various combinations. So let's say if a user wants coffee with milk and sugar, we should be able to get the correct pricing. We should not go ahead and create a subclass, separate subclass with coffee with milk and sugar, right? That makes no sense. So how can we achieve this thing using this decorator pattern is what we'll look into next. Let's first understand the class diagram and then we will move into the code implementation. So what we are doing here is first thing is like we will have an interface coffee, right? And we will keep one simple coffee as our baseline, right? This interface coffee, which will have two methods, cost and getting the description. And we'll have a simple coffee which implements this interface. And this is nothing but the baseline, like a simple coffee. What actually is a decorator? Decorator is nothing but we are providing extra things on the simple object. right? This extra things could be anything. Like, let's say if you this like you can relate this in multiple day-to-day examples as well. So when you are ordering any of the food item, let's say let's take burger, or let's say, so in burger also you have various options, right? That you can have this toppings, you can have with extra cheese, with extra paneer, or whatever. So that extra toppings which we add on the simple baseline burger, so that is what are the extra things which are getting implemented for that simple object, right? And those are the decorators for that object. So understand that in that way, it would be easier. So here also coffee, simple coffee is our baseline object, and we can have variants on this coffee, like with sugar, with cream, with milk. Those are the decorators for that particular object. So for doing that, what we are doing is we create an abstract class coffee decorator, which will hold the reference of the simple coffee, right? This reference is the reference of the simple coffee. Now we will have this decorators is an abstract class, right? So it will make sure that whatever the class is, the concrete implementation, let's say coffee with milk, coffee with sugar, and coffee with cream, which we want, uh, those would be the concrete implementation of this decorator. I mean, it would be extending this class basically, and it would be the concrete implementation. So as this decorator is extending this interface, these concrete implementation have to provide the implementation of these functions. So we'll see in the code how this is implemented. So now let's deep dive into the code. I'll put this on the right hand side and code on the left hand side to better understand it. So here we have implemented this interface coffee. So this is that interface. And we have defined a baseline object, which is simple coffee. So this simple coffee class implements this interface coffee, and it gives the cost and the description. So for the simple coffee, if user is asking, then he or she should be charged rupees 100, and the description will be simple coffee, right? Now, as I mentioned that we'll be having an abstract class coffee decorator, which will be uh, which will implement this interface itself again, and it will hold the reference of this simple coffee also. So that this is the reference of that same, like of this implementation, and we would be like whenever we'll be calling it from main, we would be initializing this reference as well. So you'll see that as well. So this is what it will do in the constructor. It will initialize the reference which is getting passed. And this is the abstract class. So we have three concrete implementation of this decorator. So like we are defining, we want this decorators to be present. This is the minimalist decorators that we want with milk, with cream, and with sugar. After that, if any of the combination is asked, like coffee with milk and sugar, coffee with milk, sugar and cream, coffee with milk and cream, sugar and cream, so all of those would be handled. And whenever the price would be sent to the user, that accumulated price would be sent. We'll also see that when we will simulate this example from the main class. So again, so this is the decorator and the abstract class. So now concrete implementation is something which we will be looking into. So this coffee with milk class will extend this decorator. Now as this decorator implements this basically the interface coffee, the concrete implementation of this class, which is extending this decorator, will have to give the functionalities implementation of get cost and get description. So let's understand right now with a very layman term that whatever the reference cost we have got plus 20 rupees would be charged to the user. Let's say reference.get cost was 100. So let's say the user asks for a simple coffee with milk, then reference.get cost would be 100 plus 20, 120 would be charged to that user. Let's say the same goes with this implementation of this class, coffee with sugar and coffee with cream. So that remains the same. So reference.get cost, whatever you are getting XYZ amount plus 30 should be charged. So let's say user asked for coffee with milk as well, like coffee with milk and sugar. So technically, the final amount that should be returned to the user should be 100 plus 20 plus 30, right? So this is how this is implemented. The decorator pattern is very simple. I mean, once you understand this, it is very simple. Now let's simulate this from our main. So here what we have done is we have created a order one, which is just a simple coffee, right? So here when I'll execute this statement, line number 6, it should return me rupees 100 and it's a simple coffee, right? So cost should be 100 and description should be simple coffee. Now at line number 9, this one, order 2, here what we have made sure that for the simple coffee, we want to add milk and sugar. So ideally, how it would work is like the final cost returned at the end would be 150 and it will be coffee with milk and sugar. So this was the naive implementation. So basically we had separate classes and each of which we were trying to uh, create on based on the different combinations which could be possible. So as I mentioned that first should be 100 cost coffee and description should be simple coffee. Now the second one is coffee with milk and sugar. So coffee, simple coffee plus milk plus sugar. So final price should be 150, right? Now let's see how this nesting took place and how it worked. So on the right hand side, if you see, so first whenever this simple coffee got passed here, okay. So this is nothing but the instance of simple coffee which got passed as in reference, right? Now to coffee with milk class. And once this complete reference is getting passed, so this reference is nothing but coffee with milk and sugar. Coffee with milk and like simple coffee plus milk getting passed to coffee with sugar. Now, how this works is let's go from top to down. So when coffee with sugar dot get cost, so basically the order 2 is holding the instance of coffee with sugar, right? So that when get cost is called, so it basically goes ahead and calls get cost of this one, coffee with sugar get cost, right? This gets hit, so it will add 30 plus reference dot get cost. So 30 plus reference dot get cost, so reference is coffee with milk here, right? Now, when cof- when reference.getCost is getting called here, so it will go ahead and call this one, coffee with milks get cost. So it will add 20 plus reference.getCost. Now, for this class, basically, we passed in simple coffee here, if you see. For coffee with milk, we had set its reference with simple coffee. So for that case, when get reference dot get cost is getting invoked for the second step, coffee with milk, that reference is nothing but simple coffee. So reference dot get cost is nothing but calling this one. So reference dot get cost of simple coffee, which will return 100. So once we'll have 100 here, 100 plus 20 is 120, which gets returned here, and 120 plus 30 is 150, which is the final cost which we are getting, right? Which we saw at the end when we ran the code, right? In the terminal. So this is how the nesting uh, works basically. Okay, this is how the nesting works. If you see here in terminal, we got 150 as the final cost. Let me reiterate again. It might be confusing in the first go. Let's again simplify. So here when this got called new coffee with milk, we are passing the reference of simple coffee. So here when coffee with milk constructor is getting invoked, like whenever we're creating new with milk or calling this basically new coffee with milk, its constructor would get invoked, and there we are passing the reference of simple coffee. So the coffee with milk class is holding the reference to simple coffee, right? Coffee with milk, coffee with milk, coffee with milk class is holding the reference of simple coffee. Make sense? Now, when we are calling coffee with sugar, right? New coffee with sugar, we are passing the reference of coffee with milk. So, when coffee with sugar is getting called, its reference would be holding this one. The reference of coffee with milk is what it would be holding. And at the end, when it evaluates in step-by-step method. This is how I have explained here on the right-hand side. And at the end, final cost return would be 150, right? If you want, you can dry run it once on your own. You will get to understand. So this is about the implementation of the decorator pattern. Now let's understand the key takeaways of this pattern. The decorator pattern implementation, we could have the dynamic layering. So we can remove or combine decorators at runtime, right? We saw that we could generate coffee with milk and sugar. Similarly, you can have at runtime coffee with milk, sugar, and cream, coffee with sugar and cream, right? Those all functionality could be done at the runtime itself. There would be no class explosions, right? Let's say we have to implement three features, which requires just five classes. So interface is not considered into class. So interface plus base component. The base component in our example was coffee, decorator base, which was coffee decorator, and the three implementation class, the concrete implementation class, which was coffee with milk, sugar, and cream. So we are able to achieve this using just five classes. Like for three features, we would just need five classes and not the eight. The to the power n minus one combinations is not required. And flexible ordering, we can have any combination, like any combination ordering of feature is possible. So here, if I reorder this, basically, if I create order 3, and this will be first coffee with milk, have coffee with sugar here, right? And this, both of this would return me the same output, is what I'm trying to say. So ordering doesn't matter. We have flexible ordering. So using this pattern, we could achieve that as well. So let's try to run it. U terminal. Okay. Need to compile. The end result remains the same, right? For both of the order. That is what flexible ordering means. Also, our code is following the open close principle. So for any new combination of the feature, we don't have to go ahead and implement subclass. With the existing three classes concrete implementation, we'll be able to achieve any combination at the runtime, right? So we are following open close principle. So I think this was all about this design pattern. I hope you like the content. If you like the content, do like, share, and subscribe. See you in some other interesting tech content. Till then, bye bye, take care, and have a nice day.